morning everyone. Today I am going to report about the topic, explain about the topic, report on Face ID control using iPad, control system engineering. Like what are the applications of Face ID in iPad in control systems engineering. So this is done by me, and first of all we will just know about the abstract of what we are going to focus upon. So Face ID is processed on device using the secure enclave for encrypted biometric data handling. Face ID is very much important for all mobile applications or iPad or anything related to such things. Then explore Face ID usage in access control systems. It mainly focuses on iPads or iPhones only. Then there are many benefits and challenges at the same time for making those devices or designed it in such a way. So no facial data is stored or transmitted externally, ensuring user privacy and data security. And these types of systems are mainly used in attendance systems, healthcare, record access, and then mainly in bank financial transactions. Now we are going to just enter into a new theme of introduction of what is control system, and mainly Face ID is used in control system of iPad and iPhones. Biometric authentication is increasingly used for secure and convenient user identification in modern digital systems. And biometrics replace traditional authentication methods. Actually, in the past and all, we all know that authentication methods were only like it will be in type of buttons. Only button systems were prevalent at those days, some 10 to 15 years and all. But now biometrics have replaced the traditional methods, and moreover, facial recognition is user friendly and non-invasive. Apple's Face ID is one such example for this introduction. Then we will just go to the overview of Face ID technology. Face ID is Apple's facial recognition system that uses advanced hardware like true depth and camera, and machine learning, which is neural engine. And let us see about what is the true depth camera. The true depth camera projects over 30,000 invisible dots to create a 3D map of the face. An infrared camera captures data even in low light. If verified, the system unlocks a grants access to be desired application or device. So it just tests whether the user is the only authorized person who is going to use that, or is some other person other than that. So it will just, this true depth camera will just analyze it and then opens the way. Next is components used in this. Facial recognition is mainly used in iPad with Face ID and iOS Face ID support. In HomeKit or shortcuts or automation apps, like it will be used in many types of automation apps. Like there are many apps, but automation apps such as ChatGPT also use these things like Face ID for opening this. And the smart locks relays Wi-Fi network iPad mode. These Face IDs are mainly used in these type of devices. Next, we will see the system architecture, which is below this. So secure enclave stores facial templates in encrypted format. Face ID authenticates via true depth camera. Face ID is one which is prevalent only, and it will be enabled only with the help of true depth camera. Without that we cannot enable that. So signal sent to the smart lock or control device, then access will be granted whether the user is an authorized user or not. Then the cloud sync or remote access to biometric data will get enabled. There will be no access to that. Next is the benefits of using this type of Face ID using in control systems or in iPads or iPhones. High security and proof resistance, hands-free convenience, easy automation, logging, and then scalable development. These are the things. Then these are the internal block diagram of this control system using iPad or iPhone. Like Face ID mainly used in control system, like in iPads or iPhones. So this is the internal block diagram of this. Next, the challenges which is involving in setting up of these Face ID systems. Like high initial cost will be one challenge for designing these types of systems. Then light environmental limitations, privacy concerns with face data, masks affect recognition. While COVID time and all, like everyone were wearing it affects the recognition. Then it will be tied to an Apple ecosystem only. The next is security considerations. On device processing keeps data private, end-to-end encryption in communication. So it will be an end-to-end contact between the messenger and the receiver. So manual override for emergencies. Supports two-factor authentication. So supports two-factor authentication means it will be enabled to Face ID and fingerprint unlocking also. Next is future scope. Let us just dive into the future scope of control systems in Face ID of iPhones and iPads. So facilitate secure transactions for patients to access health records. So it will be very much useful for patients to access those health records with the help of Face IDs used in their iPads or iPhones. Integration in institutions and public spaces. Better AI for low-lying and partial needs. Multi-user and access level support. Edge computing for faster decisions. And it will enable face-based identification for patients to access records or medication schedules securely. Then we just move to the conclusion. So the conclusion of this thing is, when we use a control system or either in an iPad or an iPhone or any type of Apple devices, it will be secure and user friendly. It overcomes many limitations, and at the same time more advancements are related to making it more widespread. Face ID offers a seamless hands-free way to interact with devices and control systems of other devices. Then overall Face ID control on iPad is a promising step towards face and smart device management. Like if a device we are going to use is enabled use, then it must be very much accessible using Face IDs such as fingerprint unlocking or Face IDs which we use. So that's all, and thank you.